In this video, I'll demonstrate how to find the equivalent resistance of a combination circuit. So this circuit is not a parallel circuit. It is not a series circuit. It is some combination of things put together in parallel and in series. So the way we do this, we have the battery here, and what we're interested in knowing is what does the battery see as the resistance of this entire circuit. So we're looking at it from the battery's perspective. What we have to do is we have to break this up into the pieces that are series and the pieces that are in parallel. In some places, that's not completely obvious. In other places, it is easier to see. So what we want to do is pick off the easy parts. So, what do we see clearly? The current is flowing through the circuit from positive to negative, so the current is going this direction. When it reaches this point, it has to choose. Am I going this way through resistor E? Am I going this way through resistor F? And then coming back to the same position. That means that E and F are in parallel with each other. Up here, we also have something that's reasonably easy to see. If current starts here and goes to this point, it has to pass through both A and C. It can't choose where to go in between those two. That means that these two are in series. Note that if we think mathematically that these are parallel lines, A and C are parallel to each other in the drawing, but they are not any parallel circuit. These are also drawn parallel to each other, and they are in a parallel circuit. So whether components of a circuit are in series or parallel has nothing to do with whether they are actually drawn parallel to each other or not. It has to do with these places where there are junctions. So here, all the current passing through A has to go through C. These are in series. Here, the current gets to decide, am I going to go through E or F? So this is in parallel. All of these resistors are 100 ohms. So when two are in series, the equivalent resistance in series is the sum of the two. So A and C combined together look like 200 ohms. E and F, to find those, you have to take 1 over each of those. So 1 over 100 plus 1 over 100, that's 2 over 100, and then take the reciprocal of that. So 2 over 100 reciprocal is 100 over 2, or 50 ohms. So what we can do is actually circle those parts and label them. Now I've drawn a circle that this circle has 2 wires coming into it. That's important. Draw it such that there are only 2 wires going in, and then this circle looks like one single 50 ohm resistor. This circle also has only 2 wires going into it, and from this wire to this one, this circuit looks like 200 ohms. Alright, now we've got 200 ohms here that is parallel to B. So any current that comes here can choose. Does it want to go through this 200 ohms, or does it want to go through B? So these two need to be combined in parallel. Over here, any current that leaves this point has to go through D, this 50 ohms, and G. There's no place where it splits off. So D, 50 ohms, and G are all in series with each other. So we can combine these in series and these in parallel. When we do that, here we get 100 plus 50 plus 100. This blue circle now has, again, 2 wires coming in and out of it, and this section looks like 250 ohms, a single 250 ohm resistor. When you combine 200 and 100 in parallel, you get 67 ohms. So this blue circle is 67 ohms. Now we're almost done, because from the battery, what we're really looking for is between here and here. And if we go through this way, we have to pass through this 67 ohms, and then this 250 ohms, and then we're back at the battery. So these two, since the current passes through both of them, it doesn't choose which one to go through, goes through 67 and 250, that means these two are in series with each other. So when we combine those, I draw yet another color. I draw a circle that includes those two parts, one wire going in, one wire coming out, and when I add those together, 317 ohms. That means the equivalent resistance that this battery sees for this circuit is 317 ohms. Remember, when you do this, in every case you should always pick out the easy parts first. And you'll be able to take the circuit apart piece by piece. And I also recommend using different colors in the same way that I did here, so you don't get confused about which number goes with which circle.